Okay, now we're going to do D3. So first we'll write down our given, and it says a 40-kilogram child is on a swing that's attached to a rope that's 2 meters long. So I know the rope is 2 meters. I'm not really sure what that is. Find the gravitational potential energy associated with the child relative to the child's lowest position after the following conditions. A, when the rope is horizontal. B, when a rope makes a 30-degree angle with the vertical. And C, at the bottom. So first of all, right off, you need to say to yourself, I need to draw a picture for this because I need to visualize it. So first of all, let's have a picture here of what's happening. Here's a swing. So if the swing is it says the swing is when the rope is horizontal. So this is where the swing's going to be horizontal. Then it's going to say when the swing makes a 30 degrees with the vertical, and then when the swing is hanging down. So I'll just call this 1, 2, and 3. And this is 30 degrees. So we really need to have a picture. So this is when the swing is parallel to the ground. It's horizontal. This is when it makes a 30-degree angle with the vertical, and then this is when the swing is down. So this is how a swing goes. Okay? Remember, this is the horizontal, and this is going to be the lowest point, is when it's on the ground. Now remember, the lowest point is going to be our frame of reference. So let's look at this. So for part A, it says when it's horizontal. So it says find the potential energy. So we know potential energy is mass times gravity times height. Now remember, the height is measured from our frame of reference, which in this point is going to be the ground. So the height is actually, this is the height, which is the length of the string. So the height is 2 meters. So the potential energy is just 40 kilograms times 9.8 meters per second squared times 2 meters. So the potential energy ends up being 784 joules. Now for part B, it wants it to find when this angle is 30 degrees. So what I need to do is, I don't know how high this is above the ground. So I have to figure that out. Okay? So there's more than one way to figure this out. I mean, obviously, you saw when I did this, I made a right triangle. Okay? So this is where you have to take your knowledge of math, and it's not the physics. The physics in this problem is just potential energy is mgh. The part that takes thinking is, let me take what I know of math and try and figure out how high this is above the ground, this height here. Well, I know this total length here is h. So what I also know is at this point, this is a triangle here. So I'm just going to draw this to the side. And I didn't draw it to scale. If this was the ground up there, remember this swing is going like this. So even though the length here is 2 meters, the length here, when it's at 30 degrees, this is also 2 meters, right? This is a right triangle. If I have, this is obviously a 30, 60, 90 right triangle. If this is 2 meters, can I find the length of the other two sides? Yeah, I can. So I would just label this. So let's say I want to find this side of the triangle. I'll call this H prime. So H prime is equal to 2 meters times the cosine of 30 degrees, because this is adjacent to the 30-degree angle. So if I do that on my calculator, $30 cosine times 2 is 1.73 meters. Now remember, this swing, when it's on the bottom, this whole length is what? 2. So this difference here how high it is above the ground at this point is going to be 2 meters minus 1.73 meters. So this height above the ground is going to be 0.27 meters. So the hard part of this problem was finding what that difference in height was. And that goes with your knowledge of geometry and just looking at it and thinking about it. Because the physics is just potential energy is equal to mgh, which is equal to 40 kilograms times 9.8 meters per second squared times 0.27 meters. So the physics is just 106 joules. That's the physics, mgh. But again, the geometry and visualization, you really can't do this in your head, can you? You have to draw a picture, right? And then the last part, part C, wants to know what's the potential energy here. Well, remember, potential energy is mgh. But here, my frame of reference, which I call base levels to ground, so the height is 0. So anything times 0 is 0. Now, I mean, you can substitute the numbers in if you want. 40 times 9.8 times 0, but it's going to be 0. And that's it. So the hardest part was part B, but again, you need to draw a picture because the picture is going to help you if you don't know what to do. When you draw a diagram and it helps you visualize, because most of us are visual, it'll help us.